children. So far we have studied about Governor's triad, Newland's law of octaves and Mendeleev's periodic table. Today we will see modern periodic law. This was discovered by Henry Moseley. That time he arranged all the elements in the form of a table called periodic table, and in that periodic table he arranged all the elements in order of their increasing atomic number, because according to him atomic number is more fundamental property of an element than atomic mass. Now according to modern periodic law, please underline whatever is underlined in the textbook. This is modern periodic law. Properties of elements are periodic function of their atomic numbers. Periodic function of their atomic numbers means when physical or chemical property of the elements in a periodic table repeats after a fixed number of elements in increasing atomic number, it is called periodic function of their atomic numbers. Now, modern periodic table is also known as long form of periodic table. In the modern periodic table, the elements are arranged in accordance with their atomic number. As a result, most of the drawbacks of Mendeleev's periodic table removed, because Moseley chose atomic number, other scientists chose atomic mass. So all the drawbacks of Mendeleev's periodic table were removed. Now, the modern periodic table contains 7 horizontal rows called periods, which are numbered from 1 to 7. Please underline the definition of period. This is the definition of period. 7 horizontal rows in a periodic table are called periods, and the 18 vertical columns in the periodic table are known as groups, that is numbered from 1 to 18. These elements were arranged in the form of boxes. Atomic numbers are indicated in the upper part of these boxes. See, in the box symbol of element is mentioned, and in the upper part atomic number is mentioned and lower part atomic mass is mentioned. Now, do you know what is atomic number? Atomic number is number of proton present in the nucleus of an atom. It is denoted by the letter Z. And we know that number of protons are always equal to number of electrons. And how will you define atomic mass? The total number of protons and neutrons present in the nucleus of an atom is called atomic mass, denoted by capital A. So, in the periodic table, there are total 7 periods and 18 groups. Apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table. You can see this is the periodic table. These are the 7 periods. 1, 2, 3, 4, 5, 6, 7. These are the 7 periods, and these are the 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is. Now you can see that below this periodic table there are 2 blocks, lanthanides and actinides. These are F block elements. So it's written that apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table. These are called lanthanide series and actinide series. So total there are 118 boxes in the periodic table. It means there were total 118 elements discovered that time. So 118 boxes were made in the periodic table. Each box contained 1 element. Very recently, formation of a few elements was also established, and thereby the modern periodic table is now completely filled. All the 118 elements are now discovered. The entire periodic table, now you can see that this entire periodic table is divided into 4 blocks. This is S block, these 2 are S block. This right hand side, this is P block. Middle, which is indicated in yellow color, it is D block, and the lower two rows are called F block. So this entire periodic table is divided into 4 blocks: S, P, D and F. S and P blocks are known as normal elements. D block is known as transition elements. F block is known as inner transition elements. So these are the 4 blocks of the periodic table. Now, in this periodic table, left hand sides are highly reactive metals. These are metals. These are also metals. Non-metals are extremely on the right hand side. These are non-metals. This 18 group, these are noble gases. They are also known as 0 group. These are noble gases. Noble gases means the elements which do not take part in any chemical reaction because their orbits are completely filled with electrons. So they do not take part in any reaction. These are left hand side are metals, right hand side are non-metals. A zigzag line can be drawn in the P block of the periodic table. Now you can see in this P block there is a zigzag line. This zigzag line indicates the elements which are metalloids. Metalloids means the elements which show the property of both metals and non-metals. We show the property of both metals and non-metals. So you can see how many metalloids are there: boron, silicon, germanium, arsenic, antimony, tellurium and polonium. These are the metalloids. These are halogens, 17. Group 17 is halogen: fluorine, chlorine, bromine, iodine, actinium. So please see the table thoroughly. You can easily understand everything. So all the metals lie on the left hand side of the zigzag line, while all the non-metals lie on the right side of the zigzag line. Means these all are metals. This is non-metal. This is noble gas. These are also metals. Lanthanides and actinides are also metals. Modern periodic table and electronic configuration. Now here is one term, electronic configuration. How will you define electronic configuration? Shell-wise distribution of electrons in an atom is called electronic configuration. You know that electrons are not present in the nucleus of an atom. They revolve around the nucleus in their respective orbits. So this shell-wise distribution of electrons in an atom is known as electronic configuration. Now groups and electronic configuration. So it is, all of you have understood what are groups and what are periods. 18 vertical columns are called groups and 7 horizontal rows are called periods. So groups and electronic configuration. Now see the group here. See, this is the first group: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Lithium, atomic number of lithium is 3. So electronic configuration is 2, 1. Sodium 11, 2, 8, 1. Potassium 19, 2, 8, 8, 1. So what are you seeing? As we move down in a group, number of shell, or you can say number of orbit, increases by 1. एक एक ऑर्बिट बढ़ रहा है. लिथियम में अगर 2 ऑर्बिट्स हैं तो सोडियम में 3 ऑर्बिट्स हो गया, पोटेशियम में 4 ऑर्बिट्स हो गया. इसमें जाओगे तो ये 5 ऑर्बिट्स बताएगा, इसमें 6 ऑर्बिट्स देगा, इसमें 7 ऑर्बिट्स बताएगा. तो व्हेन वी मूव डाउन इन अ ग्रुप, नंबर ऑफ शेल इंक्रीजेज बाय 1. दिस इज द ट्रेन. This is about group. And what you see, outermost orbit, all elements outermost orbit contains 1 electron. सबके outermost में 1 electron है. So group 1 indicates that all the elements have 1 electron in their outermost orbit. So what about group 2? It means group 2 indicates all the elements have 2 electrons in their outermost orbit. So group number indicates number of electron in their outermost orbit. Clear? All of you have understood? So this is groups and electronic configuration. Outermost electron is known as valence electron. Valence electron means electrons present in the outermost orbit. So group number indicates valence electron. Group 1 means elements have 1 electron in their outermost orbit. 2 indicates elements have 2 electrons in their outermost orbit. This way we will move. Now come to period, means moving from left to right. When we move from left to right, first see lithium 2 1, beryllium 2 2, boron 2 3, carbon 2 4, nitrogen 2 5, oxygen 2 6, fluorine 2 7. What do you see? Number of orbits are same, but what is increasing? Atomic number increases by 1. All of them have same number of shell, but their atomic number increases by 1. So when we move from left to right in a period, atomic number increases by 1. So period number indicates number of orbit. Period 1